All right, let's demystify one of the buzziest technologies out there, blockchain. We're going to break down exactly how it works and dig into why so many people are calling it a trust machine. Let's jump right in.
So, think about this for a second. In our digital lives, almost anything can be copied, faked, or just deleted. A file, a photo, you name it. So how on earth do you create something online that's truly authentic? Something you know can't be secretly changed? That's the exact problem blockchain was invented to solve.
To really get it, let's look at how we create trust right now. When you send money, you're not just trusting the person on the other end, right? You're trusting a bank, a central gatekeeper, to make sure everything's legit and that you don't spend the same dollar twice.
Well, blockchain flips that entire idea on its head. It's a massive shift. Instead of putting all our faith in one single place, like a bank or government, blockchain introduces this radical concept of distributed trust. The power and responsibility aren't in one spot. They're shared across everyone in the network.
Okay, so how do you actually build this trust machine? It all starts with creating a new kind of digital record book, or what we call a ledger. And the most fundamental piece of that ledger is the block.
So, it all begins with a single block. The easiest way to think about it is like one page in our digital notebook. This page records a whole list of transactions, who sent what to whom and exactly when. But the real magic isn't just what's written on the page, it's how that page is sealed shut forever.
And that security seal comes from a process called hashing. Hashing is a super clever cryptographic trick. It takes all the info in a block and smooshes it down into a unique code, a one-of-a-kind digital fingerprint for that specific chunk of data.
The process itself is surprisingly simple. You take the data, you run it through this special function, and boom, out pops a unique fingerprint. And what's really important to know is that this is a one-way street. You can't take the fingerprint and work backward to figure out the original data. That's a key part of what makes it so secure.
And this is the genius part. If you go back and try to change anything in the block, anything, even just adding a comma, the digital fingerprint, that hash, changes completely. It's not a small tweak. It becomes a totally different code. This means any tampering is immediately obvious to everyone. There's no hiding it.
This is where the chain in blockchain comes from. Each new block doesn't just have its own unique hash, it also carries the hash of the block that came right before it. This creates an unbreakable cryptographic link. It's like a digital chain of custody. If you tried to secretly alter block 1, its hash would change, and the chain connecting it to block 2 would shatter. The only way to hide it would be to redo the math for every single block that came after it, which, as you're about to see, is pretty much impossible.
Okay, so the ledger itself is secure. The data is locked down. But how do we prove who we are? How do we authorize transactions and show that we actually own what we're trying to send? Well, for that, you need your digital keys.
Blockchain uses an awesome system called public key cryptography. Every single user gets a pair of digital keys that are mathematically tied together. You get a public key, which you can share with absolutely anyone, and a private key, which you must protect like it's your most valuable secret. These two keys are how you manage your identity and control your stuff on the blockchain.
I really love this mailbox analogy because it just makes perfect sense. Your public key is like your mailing address. Anyone can know it and they can use it to send you things. But your private key, that's the only key in the world that can open your mailbox to get what's inside. Your public key closes the lock, only your private key can open it.
So, this is how you prove something is yours. When you want to send a transaction, you use your secret private key to create a unique digital signature. Then, anyone else on the network can use your public key, which is totally public, to check that signature. It mathematically proves that it came from you and only you. It's an unforgeable signature.
So, let's recap. We've got secure blocks of data all linked together in an unbreakable chain. And we've got transactions that are signed with these unforgeable digital keys. But who's actually running this whole show? If there's no bank, who's in charge of updating the ledger? And the answer is kind of wild. Nobody is in charge. And everybody is. Instead of one central server, the blockchain ledger is copied and shared across a huge network of computers all over the world. We call these computers nodes, and every single one of them holds an identical copy of the entire ledger. This distribution of power is what we mean when we say it's decentralized. Now, for this massive network to agree on what's true, which transactions are valid, it needs a way to reach a consensus. The most famous method is called proof of work, which you've probably heard of as mining.
Miners are basically special computers on the network that are all competing to solve a really, really hard math puzzle.
So why would anybody use massive amounts of electricity and computing power to solve these puzzles? Well, there's a huge incentive. The very first miner to solve the puzzle gets the right to add the next block of transactions to the chain, and for their effort, they get a reward, usually brand new cryptocurrency. This intense competition is what keeps the whole network secure and honest.
Now, while this whole technology was invented for Bitcoin to create a new form of digital cash, its potential is so much bigger than just money. This core idea of a secure, shared, decentralized ledger can be used for, well, almost anything.
It's also key to know that not all blockchains are created equal. You have public ones like Bitcoin or Ethereum where literally anyone can join in. But then you have private or permission blockchains, which a lot of businesses use. These are more like a private club. You need an invitation to get in, they're generally faster, and they're run by a specific organization.
And one of the coolest things to come out of platforms like Ethereum is the smart contract. Think of it like a vending machine. You put in your money, you make your selection, and the machine automatically gives you your snack. A smart contract is just like that, but for agreements. The rules are written in code, and because it lives on the blockchain, it automatically executes when the conditions are met. No middleman needed. The contract enforces itself.
And people are exploring this for everything. In supply chains, you can track a head of lettuce from the farm all the way to your grocery store. In healthcare, it could give you true ownership of your medical records. People are looking at it for secure voting, for making real estate deals faster, even for sharing sensitive genetic data securely. The list goes on and on. But for all this incredible potential, let's be real, blockchain is still a young technology. It's definitely not a magic solution for everything, and there are some pretty big challenges it needs to overcome before it really hits the mainstream.
The truth is, we're still in the early days. Public blockchains can be pretty slow compared to, say, a credit card network. The energy used for mining is a huge environmental concern, and governments everywhere are still figuring out how to regulate it all. Plus, let's face it, it can still be way too complicated for the average person to use easily. These are the big hurdles the whole community is working hard to solve right now. Which brings us all the way back to the beginning. We've seen how you can build a machine that creates trust without needing a boss. It's a truly revolutionary idea. But whether this trust machine will actually rebuild our digital world, well, that's a question that's still being answered, one block at a time. Thanks for joining me.